Hi, I'm Dr. Michael Gamble, the modern scientist, and I'd like to discuss how solar energy works. How does solar energy work? Well, as the name suggests, solar energy is light and heat energy emitted by our sun. The fraction of that energy that's radiated through space onto the Earth's surface, engineers refer to as insolation. The sun shines 10 Q of free energy onto the Earth every day. Now, a Q is a quintillion BTUs. That is 10 with 18 zeros after it. Yeah, and you thought your 50,000 BTU air conditioner was humongous. So much free energy. Well, there goes a check mark on the cost box in favor of right away deploying solar modules. Not so fast. Remember, the energy is spread over the entire surface of the Earth. That would be about 200 million square miles, 500 million square kilometers. It turns out the sun's energy that's radiated onto Earth's surface is quite diffuse. But you knew that. No one fears getting zapped when going outdoors. Our experience of sunlight is often this subtle warming effect on our faces and maybe our arms. But how quickly you can be sunburned hanging around a tennis tournament near Palm Springs, California in the springtime, or sitting on a sunny beach in Florida in summer, or even hiking in the Bandelier National Monument of New Mexico in the fall. Well, what's up with that? The sun does not deposit its solar energy evenly across the Earth. Much more energy is deposited across the equatorial regions of the planet than the polar ice caps. This is a result of the Earth's tilt on its axis, and the fact that more energy is absorbed by surfaces where light strikes them dead on rather than at a glancing angle. The more acute the angle of incidence, the less energy of the incident light absorbed. So if you happen to live in equatorial Africa or America's Sunbelt, that swath of land stretching from the eastern to western seaboards below the 36th parallel, including Tennessee, Texas, Nevada, California, well, there's one more good reason to warm up to solar energy. So passive or active solar? Well, what does that mean? Passive solar exploits building design to heat water, air, and thermal mass of buildings. Design considerations like the size and placement of windows, the kinds of insulation materials used, natural air circulation, and water storage schemes are optimized to make maximal use of the sunlight impinging on a building. If your house already exists, your only option may be to invest in an active solar installation. That is, one using active electrical and mechanical systems. Passive and active systems access the sun's free energy and have a much smaller carbon footprint than burning fossil fuels like coal and oil, and even natural gas. We've all seen roof-mounted solar panels, more properly called photovoltaic modules, because they use the sun's light to produce an electrical voltage. Well, how do they work? They use quanta of light called photons to produce a direct electrical current. This is accomplished by the photoelectric effect, a very cool effect that was responsible for Einstein's one and only 1922 Nobel Prize. That's perhaps an injustice in itself. But anyway, the effect had been noted initially by the French physicist Edmond Becquerel in 1839. But Einstein clarified the physics and elucidated the fact that although massless, photons possessing sufficient momentum are capable of displacing electrons in an atomic lattice. Now, using a suitable material, such as a semiconductor, a string of displaced, negatively charged electrons can be driven around a closed circuit. This constitutes a direct electrical current. An inverter can be used to transform the direct current into alternating current and groom it so that it can be used to power household appliances or be directed onto the electrical grid, where the utility company will be happy to sell it to your neighbors. Thank you for your time. I'm Dr. Michael Gamble, the Modern Scientist. For more information about this and other modern science topics, please visit my website at www.zeroscape-thebook.com. That's ZEROSCAPE-thebook.com.